was. All right. So Covey students began a science unit with immediate engagement and a fun activity, while always ensuring that the true science behind the fun is learned. Denton uses multiple modalities to reach her students in their learning of science.
Well, good evening, and thank you for having me. I'd like to thank Dr. Yager and the NSTA for having me here tonight. So, I am the lower school and middle school science department at my school. I teach preschool through 7th grade, and so I truly am blessed with the honor of being able to teach the same children year after year. And hopefully what I'm teaching them is not to hate science, but to love it. So I am looking at intrinsic motivation and how to foster a true love of science. So one of the ways that I foster a love of science is that I'm sure to offer something for everyone to love, even those kids that claim that they hate science. So we have a science magic club. You can see my science Olympiad team. We're a very serious organization. Graders come daily, so a lot of times I will take Monday and throw the curriculum to the side and host Mad Mondays, which is which is classroom lessons worthy of a mad scientist. So we call them Mad Monday because we do a lot of mad science experiments. We do hands-on learning, interactive notebooking. I like extreme demos. There you can see at Halloween I dressed as a fire-breathing dragon. And we host the Science Olympics every year, which is kind of like field day, but for science. So we have something for everybody to love. One of the things that I think turns a lot of students off to science is that you fail. And in math class, 2 + 2 is always 4. In English class, you can learn where to put the commas and how to spell the words the right way. But in science, there is no one perfect explanation or one perfect solution. So throughout all of my classes, and remember I'm preschool all the way up to 7th grade, you can see it does get a little bit more difficult as I go on. I like to teach my kids how to fail and to fail with grace. So we ask questions, we imagine solutions, we plan our solutions, and a lot of times they don't work. And that's okay. So I teach them how to verbalize their frustrations. I offer them guidance. I encourage teamwork. I offer age-appropriate challenges. I want them challenged, I want them frustrated, but I don't want them to not be able to figure it out. And I don't praise the end result. I praise tenacity. I praise the stick-to-itiveness. I praise their innovation and their ideas. So this is the lesson that I shared as part of my Yager application. This is an earthquake challenge that I do with my 6th graders. It's a 5E model. I use engage, explore, explain, extend, and evaluate with my 5th, 6th, and 7th. And the engage unit starts with a little computer simulation where they get to go and knock down bridges. So I don't always start with a bang. Sometimes I make them work for it. And in this presentation, this particular lesson, the bang comes at the end. They explore earthquakes. We have a mini video lesson, interactive notebook page, and a mini station lab. I like to run my station labs with both input and output stations. And the output serves as a formative assessment and allows me to focus my explanations. These are some stations that they might visit about reading a seismogram or talking about the Mercalli scale versus the Richter scale. We talk about qualitative versus quantitative. We have a cycling curriculum, so this is not the first time that they've seen earthquakes, and we like to delve a little deeper each time they see it. And finally, we elaborate and evaluate. Now, I do have a standard written test. I'm required by my boss to give written tests. But I like to evaluate their understanding of the knowledge in other ways. And so for this particular unit, I decided a good way to evaluate their understanding was to tie it back in with my engage activity and have them design bridges that would hold up to earthquakes. So you can see here their idea of having a shake table. This is somebody's drawing out of their interactive notebook on how they wanted to have a shake table and measure the seismograph of their earthquakes and test their bridges. So for me, I like to share with my students that science doesn't exist in a vacuum. With 9 preps, I can't possibly do everything, and so I rely on the skills of my coworkers. The Engage activity they actually did as a part of their computer class with the computer teacher who was working on Control-C and navigating Word documents. They typed their answers into a Word document, and the computer teacher handled that class for me. In math enrichment class, she handled the seismograph interpretation. It was a graphical interpretation. She covered y-axis, x-axis, what did the different waves mean. So she took care of that part for me. And finally, the shake table. Our Legos Robotics Club designed a shake table for us, and they used Lego We Do to design a gear that would turn the paper at 6 centimeters a minute. This was something that they engaged in the design process and refined, and it was a wonderful teamwork effort. So I like to help all of my kids fall in love with science, and I do that using multiple modalities. So there was independent work. They were working on computer skills. They were filling out interactive notebook pages. Those that like to work independently really thrived in that environment. Those that like small group work had Think, Pair, Share and mini lab stations, and those that really thrive on the energy of others had the group work of building the bridge together. Children who prefer to learn in audiovisual ways had the computer videos and simulations, the interactive notebook pages, and of course a little bit of standard lecture. But my kinesthetic learners really enjoyed doing the lab stations, squishing graham crackers, building a bridge, and being able to destroy it. And finally, there was a little bit of extrinsic motivation. They do get graded. They had a rubric, the standard things, but this offered a great deal of intrinsic motivation. There was many groups and they were in competition. Whose bridge could survive the biggest earthquake? And it is fun to make your bridges blow up. So, can your group's bridge outperform the other group? Hopefully, at the end of this unit, they saw that they can learn about earthquakes, they can apply that knowledge, and they can have fun doing science. So thank you so much, and if you have questions or would like to see my lesson plan, feel free to contact me. My email is right there.